Okay, nearly finished. Question 7 has 3 expressions, and we're asked to simplify each of them and then circle our answers. So in the first one, looking at numerical coefficients, I see that I have a 7 in the numerator and a 21 in the denominator. And probably the best thing I should do to just very clearly identify what's happening, just looking at the coefficients, I've got a common factor or a giant 1 of 7 in both the numerator and denominator. So you can see I'm going to be left with a factor of 3 in the denominator right down below. So if I take this another step forward, whoops. If I take it another step forward rather, I have x to the negative third in the numerator. In my denominator, I have 3x squared and then y to the third power. So I got to deal with this negative exponent, and my favorite way of doing that is multiplying by the number 1. So in this case, I'm going to choose the number 1, x to the third over x to the third. And the reason why I selected that is in my numerator, when I multiply this x to the negative third times x to the third, I'm going to add those exponents, right? Negative 3 plus 3, and I'm going to get x to the 0 power. Well, it turns out that x to the 0 power is the same as the number 1. So in my numerator, I've got the number 1. In my denominator now, I have 3 brand new factors of x that are living down below. So when I combine that with my 2 previous factors of x in the denominator, my answer becomes 3 times x to the 5th power, right? 2 plus 3 is 5, y to the 3rd power. So, and then I'm just going to draw a box around that. That's my final simplified version. Let's look at B. On B, I'm going to use the definition of exponentiation. I have 2 factors of 3ab squared. So I'm going to be writing 2 of those out. So I'm just going to write it's a 3ab squared, and I'm multiplying that by 3ab squared. So again, there's no terms here. It's just a 3ab squared times a 3ab squared. You don't see any addition, subtraction. It's just a single monomial. Well, I can now, of course, multiply the 3 times 3. When I do that, I get the number 9. I can also multiply a times a, and a times a would give me the a squared. And then finally, you can see that there is a b squared and a b squared. And when I multiply those out, bb would be b to the 4th power. So I just write this all together as 9a squared b raised to the 4th power. And then the final question, I've got 1 over 2 times ab to the 2nd, and that's being raised to the negative 3rd. So first of all, let's be real clear. The negative 3, right, that just applies to this. It doesn't apply to the 2. The 2 is not inside that set of parentheses. So I think probably the easiest thing to do would be to just deal with this negative exponent. So I'm going to do that by multiplying my denominator by an ab squared raised to the 3rd. And in my numerator, I'm going to write an ab squared raised to the 3rd. Again, I'm multiplying by the number 1, and you're free to do that, and it doesn't change the value of your expression. In my denominator, when I multiply this original ab squared to the negative 3rd times the ab squared to the positive 3rd, I get ab squared to the 0 power, and anything to the 0 power equals 1. So my denominator now just has the single value 2 in it. In my numerator, I've got 3 copies of this expression ab squared. So I could, let me jot this down over here. There's 3 of them, and I could write it out, right? They expand away. So it's an ab squared, an ab squared, and another ab squared. So when I look at it like that, I can see that, yeah, there's 1, 2, 3. So this is an a to the 3rd power. And I do see that I have, oh my gosh, there is no addition here. This is just multiplication. I can see that I've got a b squared, that's bb, another b squared, another bb, and then bb again, which is b to the 1, 2, 3, 4, 5, 6th power. So my answer is a to the third, b to the 6th, all over the number 2. And we'll just leave it at that.